channel. Today we are going to solve this question, search insert position. In this question basically we will give an array which is sorted in ascending or descending order, and we have to find they will give the target element, that is 5. We have to find at which position we need to insert the element in this given array in the order which is present. Like the target is 5, it should be it should be placed inserted here. So the position is 0, 1 and 2. The position is 2, so the output is 2. And the next the target is 2, so where the 2 should be present, it should be presented here. So 0 and 1, the position is 1. 7 at the last position 0, 1, 2, 3 and 4, so the output is 4. So in this question the twist is they are given us the time complexity. The time complexity should be big of log n. Basically if we do it, there are many approaches to solve this question. We can do linear search and simple approaches also we can do, but it will take more time complexity, that is big O of n. But in this question they are given us the time complexity which it should not exceed the time complexity of big O of log n. So let's see in what companies this question is asked. Okay, so this is asked in Amazon, Apple, Adobe, Google, and this all companies. This is a Google extension which tells us in which company it is. This question is asked. To get this, it is a Google extension. If you want this, you can comment me in the comment section. I'll provide you the link. Okay. Now let's see how we can do this question. This question can be done using binary search. Binary search is concept that takes a less time complexity compared to linear search. Let's see how it works. In binary search, the main thing is the array should be sorted. Then only the binary search will be working. It has two pointers, the start and end pointer. We take the mid as start plus end by 2. As we know, middle is always start plus end by 2. As we know, in this the thing is, when we take initialize it mid as int mid, the when we take int start plus n by 2, this may exceed the range of int, so it may be converted as long also. So to avoid that confusion, we can this can be written as start plus n minus start by 2. This is a simple mathematical convention which we can do to avoid the confusion between the. So you can observe here it can be converted, LCM is 2, so 2 minus start plus n by 2, this you can observe. And why we use binary search, as I said before, it will take the less time complexity than compared to linear search. Linear search basically what it does is it take the target and search from start position to end position continuously. Like it starts from the first element. If this the first element is a target element or not, then if not, it moves to second, third, fourth and so on. The worst time complexity is when the target element is at the last position. So the time complexity will be big O of n. Whereas in binary search, what we do is we divide the array and find the mid. If the target is greater than the mid, so we move to this position. If it is greater, so the target will be present in this position, right? So we will move the start to this position, start pointer to the middle plus 1 position, and end will be here only. When we observe the target is less than the middle element, so the target will be in the left side, so we move the end to this mid minus 1. So I think you understood the concept. If it is target is more than the mid, so start will be moved to the mid plus 1 position. If the target is less than the mid, the end will be moved to the mid minus 1 position. Like that, the time complexity will be reduced. So we search for the element in the less amount of space. So the time complexity will be less compared to that of linear search. Linear search, it directly takes from first element to last element. That's why the time complexity will be more. Now let's see how we take this approach to solve our problem. Okay, in our problem, as we can see, they will give us an array. This is the example which I'm taking, and target is 5. Okay, As we know, the in the binary search we'll take the start as 0 and end as the last element. Nums minus length, nums minus nums dot length will give us the length of this array minus 1. So 4 is the length of the array, minus 1 will give the index of the last element. So 3 is the index of last element. So what is the mid? As I said, the to avoid the range complications, we do this formula: start plus n minus start by 2. This can be simplified. We'll get the normal thing only: start plus n by 2. If we do the 3 by 2 will be 1. So the mid will be 1, 0 and 1. Mid is 3. Next step is we have to check if the target is greater than the middle element or it is less than the middle element. We can observe that the target which is 5 is greater than the middle element. So what we have to do, we have to move the start pointer to mid plus 1. So what I did is that only mid plus 1. What is the mid? Mid is 1. So 1 plus 1 is 2. So as we have to implement the same formula here. Mid is equals to start plus end is the same, end will not change, end minus start by 2, it will be 2. What is the 2? 0, 1 and 2. 2 is fifth element. Fifth element target is equal, if target is equal to mid element, then we have to return mid only. If it is greater, then we have to do this. If it is less, we have to move to the left position, and should be moved to mid minus 1. If it is equal, we have to return mid. Now let's, I think you understood the concept. Let's move to our question. Okay. Okay, in binary search, first what we have to do, we have to initialize the start as 0 and end as length of the array minus 1. Minus 1. So we have to take the while condition. It should run till start is less than or equal to end. Till that condition, it should the loop should continue. We have to take the mid is equals to what, as I said, start plus end minus, sorry, end minus um, start by 2. Okay, then we have to apply the conditions, the three conditions. If target is less than nums mid, then what we have to do, we have to move this end is equals to mid minus 1. Okay, else what we have to do, else if target is greater than mids, it will be in the right position. So we have to move the start only. Start is equals to mid plus 1. Okay, if not, what is the other condition? Other condition is that both are equal. What we have to do when both are equal? We have to return mid itself. That's it. Okay. If not, what we have to return? We have to return the start element. What is this? If not, means normally when we do the binary search, this last return, what I wrote this return, the last return statement refers to the element is not present in the array. But in this question, what they are asking, the position at which the target should be, the index at which the target is placed. When the target is not present in this given array, we have to place it in the first position. Like here, when this 2 is not present in this array, so it will be in the last condition. What we have to do is, at this position we have to place the before element, we have to place. So start, we have to return start, the index of start. That's it. Let's run this. What I have done here, okay, I kept dot instead of comma. Okay, yeah, accepted. Let's submit our code. Okay, cool. Yeah, thank you for watching, and stay tuned for more videos like this. Thank you for watching. Bye bye.